one that looks like this one, has a lot of carbon on the top of it, we do not take it to a wire brush and clean this carbon off. Okay, the pistons are specially coated. They have a coating on them, and if you use a wire brush, it will strip the coating off, and the carbon, instead of sticking to the top, will actually embed into the piston. It actually makes it weak. You could cause it a melting spot. It will actually overheat and cause it to melt. Once you get past the rings on the side, just below that, again, is the board for the piston pin. The pin goes in there. Most of the pistons that we'll see that we use in cars, they are what we call a slipper. They have very long, the skirt is long here, but it's cut out here. Okay. This cutout here is actually to miss the throws on the crankshaft. Okay. It's designed that way. It's the wrong one. If you look at it like this, the slipper actually misses the counterweights on the crankshaft, but it's still longer on this side. We have two sides to the piston. And normally when you can get them out, you can look at them. We have a, whichever way is the front. Remember I told you these have a F on them for front, faces the front of the engine. You look at it, one side is the thrust side of the piston. That's the side that's constantly moving up. Remember when the crankshaft is pushing it up, it's actually thrusting it up. It thrusts it up and it sort of gently pulls it down. It'll push it down. The thing too, remember when the crank gets to the bottom, this connecting rod has to change direction. So the forces actually change on it. We come down, we hit bottom dead center, then the crank wants to push it up like that. So it's going to tilt the piston, it's going to cock it, and it's going to go up at an angle on the cylinder wall. Now you may see some slight scuffing on that thrust side. A lot of times it can be negated. It's not that important. You don't want to see deep scars though. If we're seeing deep scars, there's an issue. And more likely it's the rings. The rings have gotten weak and they can't hold it off the cylinder wall. Okay? So again, one side's the thrust side, the other side's just a return. But the thrust side is going to have a little bit of scuffing on it. Okay? Then most pistons too, if you look at them really, really close, they're going to be little lines machined into the side of the piston. And just like we talked about the cylinder walls, cutting lines into them, same thing. Those grooves are there to hold oil. So when it does get thrusted and it does go for the cylinder wall, it actually doesn't touch. It's the oil between it that cushions it to keep it off. Okay? But we want to look, we want to make sure the lines are in the side of the piston. Some of yours are worn somewhat badly. But that's important when you're rebuilding an engine. Look at it. Again, it's an inspection process. You want to make sure that the slipper is not broken or chipped, because that changes the weight of that particular piston. When you get into a truck engine or heavy duty stuff, they use a full piston. It is not skirted like this. It's not cut out. It's almost like a big old soup can when you look at it. It's straight and it's same thing all the way down. Still has the rings and all and the pin, but it's straight all the way down.
So what do you call it?
Full skirt. This is a slipper. This is a slipper as opposed to a full skirt. But again, most heavy duty applications.
Thank you.